One of the biggest parts of it is the growth of renewables. And within the report, it describes it as Herculean. What's Herculean about it?
So we currently have around 50 gigawatts of installed renewable capacity here in Britain, and the targets in Clean Power 2030 set that to be between 120 and 130 gigawatts-ish of renewable capacity. If you kind of compare those historical build-out rates, say for offshore wind, we would need to have up to 5 gigawatts of offshore wind coming online per year between now and 2030, and we've historically had about a gigawatt coming online. But at the moment, we pay, or NESO pays, around £1.5 billion on these balancing costs to manage the transmission constraints, which works out roughly about £50 per household. If we left the network exactly as it was, NESO say that cost would go up to £12.7 billion per year by 2030. So that's an increase of £450 per year for each household. Politically not viable.
Up to 130 gigawatts of renewable generation will be required for Great Britain to reach its clean energy targets as laid out in the National Energy System Operator's Clean Power 2030 report. With 50 gigawatts of renewable generation currently on the system, there is a long way to go to meet these targets. In today's episode, Modo Energy Market Analyst Joe Bush joins Ed Porter to discuss what this Herculean effort will involve, what challenges the industry might face along the way, and what it means for battery energy storage. If you're enjoying the podcast, please hit subscribe so you never miss an episode, and give us a rating wherever you listen. Let's jump in.
Hello and welcome to another episode of Transmission. Today, I'm joined by Joe. Joe, welcome.
Thank you, Ed. Pleasure to be here.
And Joe is one of Modo's analysts. So, Joe, perhaps we can kick off by asking you, who are you and what do you do at Modo?
Yeah, great. So I'm a market analyst here at Modo. So I'm in our research team here, publishing research and analysis and focusing on our forecast product. So we produce a forecast of future power market prices and battery revenues, and I help to kind of digest the key trends there. So I spend my working life thinking about the future of power markets and get, quite excited about new visions and plans for what that might look like and try and compare that to our own internal view here at Modo.
Okay. And from the future to the past, what does your kind of what's your history in this space?
Yeah, so I've been at Modo for just over a year now. I started my professional life as a carbon accountant at a sustainability consultancy, so working out for big corporates what their carbon footprint is. From there, I moved to Triple Point, who are an investment manager, so kind of investing in energy projects, so renewables, energy storage, and I got a kind of view of the decisions that investors were making around these kind of infrastructure projects, infrastructure investment, and that kind of thing, and then came to Modo.
So how do you kind of so it's like, how do you turn the kind of concept of things like flexibility into an investable piece, and how does that then attract the capital to get built, which is probably a pretty critical part of how we're going to think about Clean Power 2030.
Exactly, yeah. I think a lot of these plans are very expensive and they have to make sense from an investment point of view as well. If you're managing somebody's money, somebody's pension to put into these projects, it needs to be viable.
Yeah. And we've kind of snuck that into the conversation, Clean Power 2030. But last week we saw a publication on Clean Power 2030. Who produced that publication and what was it?
So that was produced by the National Energy System Operator, NESO, here in GB. And it's kind of a legacy of when the new Labour government came into power earlier this year. One of their manifesto promises was to make Britain a clean energy superpower, I think they called it. And a kind of corollary of that was we wanted to achieve clean power by 2030. So NESO, as it's now known, one of its first tasks was to go away and figure out how we do that, essentially. And they've written a whole report on it called Clean Power 2030, in which they give the key takeaways and the things that we would need to do to achieve clean power by 2030.
Yeah. And maybe starting with that exact thing, Clean Power 2030, like what does that mean as a target? Like what are we actually aiming for?
Yeah, exactly. So I think that was kind of their first challenge, right? It was like not the kind of most well-defined brief from the government. So their first challenge was to kind of look at the system and create a definition for clean power by 2030. So the one that they've come up with in the report, but not necessarily the one that the government has to use in the future, is that it's a kind of power system where 95% of generation comes from clean power sources. So that's renewables, biomass, nuclear. and there's an additional 5% that's coming from unabated gas generation. So, say a CCGT that doesn't have any carbon capture and storage technology attached to it.
Yeah. And so if you kind of imagine like where we might spend that 5% of kind of thermal or gas-fired generation, in a kind of standard year, does that mean we're going to be running gas for like 5% in every period, or is it going to look different to that?
Yeah, so I think the distribution would be much lumpier than that, really. So the way that NESO have seen it is that we would have a similar amount of gas generation capacity on the system in 2030 as we do now. It's just used much less frequently. So to give an example of when gas generation might be used, last week here in the UK, and I think across a lot of Europe, we had pretty awful weather, definitely not a sunny start to November. So still cloudy, dark, very little wind and solar generation on the system. And we had to spin up a lot of gas to compensate for the drop off in renewable generation. So kind of increase in prices. And yeah, that gas was compensating for the loss there.
It was quite interesting because in lots of places, people kind of came on to various places like, I don't know, LinkedIn, and said, oh, this is a real problem. Like, look at this. This is a real problem. How do we do this? And I wonder if actually kind of part of that definition around clean power is saying, well, yes, that is going to be a difficult period, but look at what happened. We had those conditions. We had high prices. High prices got thermal plants to turn on. And yes, we had some high price periods, but we were able to deal with that because we have the gas fleet that we can rely on for that particular period of time. I suppose it's then how do we go beyond 2030 that's perhaps the interesting part of how do we get to a fully clean power system.
Yeah, exactly. I think it's those incremental extra percent, so 96, 97, 98% clean power will be, each percentage point harder than the last, essentially, as you try and force that last little bit of gas off the system. So I think the definition that NESO have come up with is kind of a sweet spot where we don't have to spend kind of loads and loads to eliminate that little bit of gas generation at the end, but enough that kind of the majority or the vast majority of power is coming from clean generation sources.
Yeah. And we're starting to hear some rumblings around like potentially things like strategic reserve being looked at, which is kind of similar to the coal-fired contracts that were existing, which is this idea that there'll be some plant that's available if we need it, but it won't be included in the main wholesale market.
Yeah, exactly. I think because if you're having the same amount of gas generation capacity online, but you're using it a lot less, obviously commercially there's investors in those gas plants. They need that to make sense to stay online, really. If they have flat costs for being online and ready to go, they need to recoup that somehow. So I'm sure that the government will have to look at something like the strategic reserve in that case as well.
One of the interesting things from the markets forum that came out yesterday was talking about the gas plant, how some of that gas plant is getting slightly older in life. And so there is definitely some thinking that might need to be done around how do we kind of keep that gas plant on, but not having it running for long periods of time. So I think it's an interesting kind of dynamic going on within the space. But let's get back to kind of Clean Power 2030. So one of the biggest parts of it is the growth of renewables. And within the report, it describes it as Herculean. What's Herculean about it?
So it's probably the kind of unprecedented build out rate of renewables that is Herculean, I guess, alongside all of the supporting infrastructure as well. But to focus specifically on renewable build out. So we currently have around 50 gigawatts of installed renewable capacity here in Britain. And that's come online or been built out really, I guess, in earnest over the past 15 years or so. And the targets in Clean Power 2030 set that to be between 120 and 130 gigawatts ish of renewable capacity. So more than doubling the installed renewable capacity. So wind farms, solar generation in 5 years compared to the kind of 15 years over which we've built out that initial 50 gigawatts.
Okay, so the rate of renewable deployment is going to fly. How are we going to achieve that?
It's going to be difficult, I think. So if you kind of compare those historical build out rates, say for offshore wind, we would need to have up to 5 gigawatts of offshore wind coming online per year between now and 2030. And we've historically had about a gigawatt coming online.
So this kind of unprecedented build out of renewables, we have this growth in renewables up to 120, 130 gigawatts from the 50 gigawatts today. The rate of that build out, how does that compare to what we see on the system today?
Yeah, it's quite significantly higher, really. So, for offshore wind, as an example, the report calls offshore wind the backbone of this renewable system. So, that sees the highest build out, and that has up to 5 gigawatts of offshore wind coming online each year, up from a kind of historical rate of about 1 gigawatt per year. And to put that into perspective, so the Hornsea array of wind farms, so three kind of record breaking big wind farms off the Yorkshire coast, that is about 5 gigawatts in total once Hornsea 3 comes online. And that array kind of covers an area similar to the size of Greater London. So we need that coming online every year between now and 2030 to meet that build out of offshore wind.
Okay. And actually to enable that, right? So it's both, yes, we need this vision of where we're going to, and we need the financing for these projects, but there's also a logistics side of this, right? So how do we get the supply chain to be able to handle that kind of increase? So if year on year we typically add 1 to 2 gigs of wind, how do we step that up to these new record levels?
Yeah, it's tough. And I think so. There was some analysis recently from Regen who looked at the typical lead times for these projects. And I think they said for offshore wind, it was typically from submitting planning permission to an operational wind farm took around 7 years on average. And that's to kind of do all the paperwork side of things, the planning side, but then the kind of lead times on those significant components that you would need for a project like that, the cabling, the transformers, the wind turbines themselves, it all takes a long time to source. You obviously have to get all of those components together in one place to build the project. And yeah, they take a long time to build out.
And I think that's probably the kind of one of these big things about Clean Power 2030 is that we're essentially into 2025 already. Planning for big projects can take up to 7 years, as you say, for offshore wind. And I think it's similar for transmission build out. And then you need to buy like big bits of power electronics. So we're not talking about kind of the small inverters you might see at home, but you're talking about kind of the 132 kV transformers. These are big bits of kit that might take 2 to 3 years to order. And so if you kind of stack up the planning and the time to order these pieces, getting stuff done by 2030, it feels like a lot of that will have to come from projects that are already in flight.
Yeah, exactly. So it'll probably have to come from, projects that are already in the pipeline, projects that, for example, have already secured contracts for difference in the allocation rounds there. So that, kind of government subsidies for these things. So, but the rate of those wouldn't be enough to meet that 5 gigawatts per year. I think our wind build out that we project in our power market forecast, we have about 3 gigawatts per year on average, kind of ramping up towards 2030. So still a significant gap.
Still an incredible step up, but maybe not quite hitting the Clean Power 2030 target. Maybe we'll come back to that in a second. But with the build out of wind alongside other forms of renewables, we kind of have to get a network that matches it. And so another part of Clean Power 2030 looked at networks.
Yeah, exactly. So I guess one of the kind of big problems with this renewable build out is getting the power from where it's generated, which is typically, say, offshore wind off the east coast of England, so the Hornsea array that I mentioned earlier, or kind of onshore wind in Scotland. You need to get all of that power from where it's generated down to where it's consumed, which is typically kind of where we are in southeast England, London, those kind of big urban centres around the UK. And to do that, you need to build out transmission infrastructure, essentially. So we have a kind of problem at the moment with constraint costs. So when it's really windy, for example, the wind that's generated in Scotland can't make its way down to where we are in London because of constraints on the transmission network. There's just not enough capacity to get it down here. So NESO currently has to curtail that wind in Scotland and ramp up what is typically kind of gas generation closer to these demand centers to control those constraints as well. So not only does that add more gas to the system, it also increases costs for consumers. So I think without a significant build out of transmission alongside that renewable build out, it's going to be expensive for consumers and difficult to meet that 95% level of clean generation.
Mm-hmm. And maybe just a point on the constraints, right? So each of those transmission lines that can carry power is rated for a certain amount of power. you can't run more power than that down it, because you'll have things like overheating the lines, and then you have a risk of them breaking. So that's kind of why it's limited. Okay, and just to maybe actually one thing on the constraints. So you talked about ramp up of gas assets, but maybe actually this is a nice opportunity to talk about a little bit of flexibility. So we do also see storage assets being used for that as well. So it's not just a gas play, I'd say.
Yeah, exactly. So that's, I guess, one of the big USPs of batteries, which is what we focus on mostly here at Modo all day. So if you have a battery, say a battery located in Scotland, when those constraints develop and a wind farm in Scotland can't send its power down past the B6 boundary, separated Scotland and England, a battery in Scotland can instead charge with that power and then release it when there's less constraint or when there's more demand. So they kind of smooth out the power flows and allow the NESO to kind of balance those transmission requirements.
Yeah. Maybe coming back to that constraint points, because I think this is probably one of the most critical parts of the whole Clean Power 2030, which is that we're building a lot of wind in Scotland because that's where the sites are for the offshore wind, and that's where the best wind data is, or the best wind. So the best wind speeds, the best consistency through the course of the year. And so people want to build wind turbines there with good reason. One of the issues that we have, though, is if the transmission lines don't get built out at the speed we expect, some of those constraint costs can be quite scary. So already like quite an expensive cost of electricity to consumers. Like what does the range of those constraint costs look like?
Yeah, it's pretty significant. I think the kind of cost of doing nothing and keeping the transmission network as it is quite significant. So at the moment, we pay, or NESO pays, around £1.5 billion in the kind of year to date on these balancing costs to manage the transmission constraints, which works out roughly about £50 per household in GB has to pay for that kind of rebalancing to manage those transmission constraints. If we left the network exactly as it was, NESO say that cost would go up to £12.7 billion per year by 2030. So that's an increase of to £450 per year for each household.
Yeah.
So quite a significant monthly cost for the household that is probably politically not viable.
So that's clearly not viable at like £450 per household per year. But obviously NESO have got big plans to reduce those constraint costs via network build out. So they talk through this in Clean Power 2030, but what do some of the other options look like for those constraint costs?
Yeah, so they have kind of a range of, I think, about 81 projects that they would want to see kind of fast track to completion by 2030. So I think they say that's kind of 1,000 kilometers of onshore transmission lines, and then 4,500 kilometers of offshore transmission lines. So that's big, essentially similar technology to interconnectors. So running down from Scotland to the east coast of England, these offshore cables that can kind of pipe power directly into the grid and bypass a lot of those current transmission constraints. And NESO says that if all of those projects were to come online by 2030, then the kind of cost would reduce down to 3.6 billion. So double what it is today, but still kind of not at that 12.7 billion end of the range. So yeah, those transmission projects would kind of significantly reduce that cost burden down to what would be probably more politically viable for an end consumer to see on their energy bill each month, essentially.
Yeah. And it also feels like there's kind of another kind of key part of this, because at the same time as Clean Power 2030, we've still got the parts of REMA kicking around. And I think Desnes yesterday were talking about potential decision on national versus zonal within REMA within the next 6 months. So we're in November, so by April, we'll see. We'll see how those timelines hold up. But it feels like if one of the ways of kind of solving constraints is building out more transmission, that is a good way of resolving those constraints. But the downside is that actually, if you try and solve all your constraints with just transmission lines, you can end up with kind of almost like a gold-plated system. So you spend loads of money on transmission, but you don't use it a huge amount. And so actually the overall cost to consumer is kind of higher. And so things that are being looked at there are probably the two major ones would be, one would be flexibility, but maybe let's talk about the REMA design piece, which is a national system versus a zonal system. How might that change kind of what this looks like?
Yeah, exactly. So I think a lot of these transmission costs would be based on national pricing. So you have a single price across Britain, and there's no incentives for anybody to consume power. So whereas a load of the wind generation might be being generated in Scotland, there's no incentive for me as a kind of big, say, industrial user of power or a data center using a lot of power to locate in Scotland to use that power and minimize those transmission requirements. So a move towards a zonal pricing system, which is what a lot of people kind of advocate for, would see different prices in different parts of the country and kind of incentivizing demand to locate where generation is. And this is something you see in other countries as well. So Norway, for example, has a clear price gradient. There's a lot of renewable generation in the northern edge of Norway that can't make its way down south on the transmission network. There's a zonal price there, which means power there is a lot cheaper, and you get people like big data center companies wanting to locate their processing there to use that cheaper demand essentially. So that could, if we were to implement a zonal price here, that could kind of fundamentally change some of these transmission build out scenarios, because you incentivize demand and generation to locate together and you minimize the need to transmit power between the two.
Yeah, so we're not kind of saying you can lift out this kind of North Sea wind farm and pop it in kind of the Thames. We're saying actually, if you've got a data center that doesn't really mind too much where it is, or if you've got some kind of industrial process that's kind of heavy demand, if you could incentivize it to go to Scotland, you might be able to save yourself some of the transmission build out.
Yeah,
okay.
Exactly.
Interesting. Well, in the next 6 months we'll find out.
Hopefully we'll have to rewrite the report.
yeah, exactly. And then maybe to the other side of it, so the flexibility side. So we've touched on this very quickly in terms of how storage, for example, releases constraints in the system today. And there's a kind of a whole load of nuance around that, because there are some kind of some technical pieces that we maybe won't go into, but at a high level that is like a way of releasing constraints. What does the report say about flexibility?
Yeah, so the report sees a big increase in the capacity of these flexible sources. So I guess, looking specifically at energy storage. So it has a role for battery energy storage, BESS, and long duration storage, which is, I guess, technology agnostic, but could be seen as either pumped hydro storage or long duration batteries as well. So for BESS, it sees an increase from about the 4.5 gigawatts that we have installed today up to between 23 and 27 gigawatts. Which is quite a significant build out. Again, I think that's higher than we have projected here at Modo based on the current pipeline of batteries that are in development. And it also sees an increase from about the 3 gigawatts of long duration storage up to around between 5 and 8 gigawatts of storage. And there'll have to be some incentives, I think, to get that storage online. I think particularly for long duration storage, we've not built any of that in Britain for 40 years, I think, since De Norwig came online in the 80s. So if they kind of want that to come online, there would have to be some kind of incentive there, I think, to enable investment in those technologies as well.
It feels like, of the things we talked about so far, offshore wind will go through allocation rounds to get a clear signal as to kind of how much to build. And then we'll see transmission, which is already being planned and kind of has to already be planned because it takes quite a long time to come through. But clearly there's a kind of a process for building that out and a way to kind of for that to be financed and built. But for flexibility, it feels almost like the odd one out, in that it's kind of like the kind of market will say, let's just build this and it'll happen.
Yeah, exactly. And I think, it's kind of left up to the market to build out this storage. And I think partly that's probably, I guess, NESO is new in its role of central planning. They're used to planning these transmission build outs. They're used to produce the network options assessment, the electricity 10-year statement and that kind of thing. But kind of haven't historically done as much of this more central planning of things like battery capacity or long duration storage. I think there'll probably need to be a bit more done there to see how we incentivize those onto the system. But things that are currently in flight, like the potential cap and floor scheme for long duration storage, should go some way towards meeting that. So providing a level of revenue certainty to investors to enable them to invest in these projects that are kind of inherently risky and bring them onto the system.
And I think that's kind of it's a really interesting point, because I'm not actually sure that all storage owners or investors are kind of crying out for more involvement or more of like a centrally planned involvement. So if we kind of look at the pipeline for batteries out until 2030, I think there's something like 70 gigs potentially that can be built, and Clean Power 2030 looks at about 30 gigs. And so 40 gigs of those battery storage projects won't be built by 2030, just kind of running the clean power numbers. And I think one of the dangers with that kind of the LDES scheme is it's kind of saying, okay, we centrally think this is required and we're going to kind of step in and try and make this happen. I think there feels like two parts here. One is kind of you allow private investors and private developers to make decisions about where to locate based on the connection costs they have, the land agreements they have in place, and their kind of decisions about what they want to put where. And the other side of this is you have more central involvement, and someone gets involved and says, okay, we think that this is the direction we want to go down, and therefore these are the 30 gigawatts of projects we want to pull through. I'm not sure that developers in the UK would be that thrilled with that process. They'd be very thrilled if they were selected, but if they were in the 40 gigs of projects that don't get selected, I could see that being a really kind of hard process.
Yeah, it is a tricky one, and I think any kind of scheme design like that needs to be careful to not skew the market in any significant direction. And I think, yeah, it's probably important in the scheme design, which is, I think, still being fleshed out importantly, right? So we don't have the finalized details of what that scheme would look like. But I think any scheme that did come online would need to clearly define the problem that it's trying to solve. So if it wants 8 hours storage, 10 hours storage, and then be relatively agnostic about how that's solved as well, to allow different technologies to compete and for the kind of market to find the best solution for that problem, rather than, say, picking winners in, a development pipeline of batteries, for example, which is, much more, I think what developers probably wouldn't want to happen there.
So I think we've gone from kind of a general look at flexibility, and you've more explicitly talked about LDES there. So the long duration energy storage LDES, that is looking for battery projects that are longer than 6 hours. But in the first round of drafting was explicit that it didn't want lithium to be taking part. Now in the second round of drafting says something along the lines of only projects that are uneconomic will be ones that we will support. So they're effectively saying there's a problem in the market. The market's not recognizing how valuable long duration storage is. And so we have to step in. We have to step in and do something about it and pay extra money to incentivize people to turn up. And then they're saying, or in the first draft, they were saying, and that can be everything but lithium. And now they're saying, okay, if the lithium's not economic, then it could come in. That's kind of where we've got to. But this feels like actually it's quite nuanced, but maybe we should just take a step back from it and say the whole point of doing this is because you want the lowest cost to consumer. And so if I kind of say to you, like, how would you design LDES? Like, what would that look like for you?
Yeah, I think it is interesting. So I think, I would, as you say, take a step back rather than saying specifically, we don't want lithium, we don't want technologies that aren't commercially viable, whatever. I think to take a step back and work out the need for a specific duration. So if they look at the system in 2030, for example, we have this 130 gigawatts of renewable capacity online, and they do some sensitivity analysis, say with different weather years, different weather scenarios, and see actually we have like a critical period of really high prices, potential loss of load that lasts over X hours of duration, for which we need storage. That storage is not commercially viable because this is a one in every 2 years, 3 years, 5 years scenario, and nobody's going to build it for those high prices in 1 week of the year. That's the problem that they need to solve, that the market is not going to solve itself. And then they can go back and say, right, we need 12 hours. What is the cheapest cost to consumers, essentially, technology to provide that 12 hours of storage that we think we need to provide a resilient kind of energy secure system in 2030.
And I think just that's kind of similar to what we've seen in other regions, right?
Yep.
So if you look in Australia, if you look in California, quite developed storage markets, that's kind of what they've looked for, and they've been kind of happy to accept what comes through that wants to go into those durations. Yep. I think when we look at lithium, we see a lot of kind of 2 to 4 hour systems being developed, but not so many in the 6 to 8. And so it'll be really interesting to see whether that scheme starts to incentivize and bring through some of those longer duration pieces.
Yeah.
I suppose the last part of the flexibility question is, okay, they want 25 to 30 gigs of flex outside of kind of there doesn't seem to be that process in place right now to enable that. The work that seems to be going on is kind of the connections work and things around things like skip rates within the control room.
Yeah.
But is there any indication in terms of extra work or extra incentive that might be given through Clean Power 2030 to bring some of those, or to bring that 30 gigs of storage to life?
Yeah, so I don't think specifically, I guess the big enablers would be those grid connection piece. So a big part of the Clean Power 2030 is accelerating the rate at which people can get grid connections to bring this power online. As you said, there's a massive pipeline of battery projects that are wanting to come online that developers have ready to go essentially, but are limited by the rate of those grid connections. So I think that will be one of the key enablers for the technology there. I guess on the longer duration side, the potential cap and floor, although that's not specifically mentioned in the report. But aside from that, I think there'll probably have to be work to be done if we are to achieve that 27 gigawatts of batteries, to work out how that's incentivized, whether that needs any kind of central planning type support or whether the market itself brings that online.
Okay, Joe, well, thank you very much for running through everything on Clean Power 2030. 2 questions to finish up. So first one, have you got anything that you'd like to plug?
Yes, so as I mentioned at the start, I'm producing research and analysis here at Modo. So published a piece yesterday on Clean Power 2030. So we have a big free section at the start where we look at some of the specific plans, some of the things we've talked about today, and then a section at the end as well, specifically on how that impacts batteries and battery revenues, which is what we kind of focus on here. But I'd plug that, my research output here at Modo.
Okay, incredible plug of your own work. Well done.
Thank you.
And maybe I'd plug on that. So if ever you want to get in touch with anyone who's put together a research piece, feel free to kind of go through the platform and get in touch, or you can email Joe directly and talk through how that comes together. And maybe the last question from me is on what are your hopes for the kind of Clean Power 2030? What does an ideal outcome look like for you?
Yeah, I think it'll be interesting to see where it goes. So in terms of next steps from this report, so the government told NESO to kind of go away and come back with how they could achieve clean power by 2030. I think the ball is now kind of firmly in the government or Ed Miliband's court to work out how to interpret this, digest it down, and come up with a kind of actionable plan. And I think in doing so, he will obviously be keen to minimize the total cost to consumers as well. I think that's one of the big reasons for doing all this. It's to minimize these kind of supply shocks we have with gas prices driving consumer costs through the roof, to make a kind of more resilient and secure energy system. So I think overall, in terms of the ideal outcomes here, we've obviously seen that this is going to be very expensive in terms of the initial upfront investment and the kind of required infrastructure build for all of this to happen. I think in terms of how that gets piped through to the end consumer, there should be some kind of careful analysis of what would be best there. So keeping in mind those potential constraint costs, for example, whether we move to a zonal system, that kind of thing. And just, always keeping in mind how we can minimize the cost of the consumer, get everybody on board with this net zero power system and not make it some crazy expensive thing that you see on your energy bill every month, I think will be really important and the kind of crucial element that lets all of this fall into place.
100% agree. Joe, thank you very much.
Great. Thanks, Ed.
Thank you for listening to Transmission, a Modo Energy podcast. Transmission delivers conversations from industry leaders and experts exploring energy markets and the operations and technologies related to grid-scale battery energy storage. Check out our other episodes by searching Transmission wherever you get your podcasts. Check out the Energy Academy, our video crash course on how markets in Great Britain and ERCOT work, or head to modoenergy.com to see our written research. Thanks for listening.